Well, this part is about what are the equations of movement for a motion that is a rotational motion in the case that the angular acceleration alpha is constant. If the angular acceleration alpha is constant, means that the change in the angular velocity is constant per unit of time. So from this equation, you can find easily this equation. We did it before when we use instead of alpha a instead of omega v, v0, etc. So the omega z of t that depend of t is the initial velocity plus the change, and the change is alpha by t. So you can do it here. I did it here. Let's go downstairs. Let's go downstairs. Sorry. So if alpha is omega minus omega 0 by delta t, omega final is omega 0 plus alpha by delta t. We choose t0 equals 0, so t minus 0 will be t. So not 0, it will be t. T minus 0 will be t in a way that omega of t will be omega 0 plus alpha t. But this is a rectilinear line. If you draw omega as a function of t, this is a rectilinear line. At t equals 0, omega is omega 0. And the omega is increasing because there is an acceleration. The omega, the angular velocity is increasing. Meanwhile, alpha of t is just a constant. It's just a constant, alpha 0, let's say. So omega is increasing, and the equation for this alpha 0, let's say alpha 0 equals 3 radians per second square. 3 radians per second square means that the angular velocity is changing in this way. Omega of t equals omega 0 plus alpha t. So, to obtain an equation, a motion for theta of t for the angle as a function of time is very similar as we did with position and velocity in movement, in motions with constant acceleration, constant linear acceleration. And the way was like this: the average angular velocity, because this is a rectilinear line, the average between 2 points, T1 and T2, T1 and T2, the average velocity or the average angular velocity is omega final plus omega initial divided by 2. Is something in the middle here. Something like this. It covers the same area. This is the average omega. But the average omega, that is omega final plus omega initial divided by 2, the average omega is delta theta divided by delta t. But omega final is omega initial plus omega 0 by delta t. Omega final is omega 0. Omega final is omega 0 plus alpha t, omega 0 plus alpha t plus omega 0. So it will be 2 times omega 0 divided by 2 will be only omega 0, and here it will be 1/2. So this will be theta minus theta 0 divided by t. So you have this equation of theta of t very similar at the other equation that we have found. So let's go to review it here. Let's go to review. This equation, this is the comparison between the two cases. In the first case, you have the linear acceleration constants, the velocity change like this, the position change like this, we know. Vx change like this, we have seen this kind of equation. And the delta x is 1/2 of the v final minus v initial, v final minus plus v initial by t. So in the case that the motion is with rotation, in the case that the angular acceleration is constant, omega z is like this, very similar. See the comparison. You change alpha by a, and you get the same omega by v, and you get the same equation. Theta is this equation. You change the x by theta, the v, the velocity v by omega, and the acceleration a by alpha, and you obtain this equation that I have shown you here. Okay, so compare this equation, compare this two-side equation with a fixed axis, angular acceleration, fixed axis, angular acceleration, compare these sets of equations with this set of equations that is constant linear acceleration, and see what you have to change from here to obtain this equation. It's clearly that what you have to change is the a by the alpha, the v by the omega, the x by the theta, and you obtain that same set of equations. That's all.